All right, let's do the practice. For skills test number 11, let's record the solutions here and see if you can follow along. All right, for each of these equations below, build a sign chart and use that chart to sketch a graph of whether the graph is above or below the x-axis. So an x tells me I need to have a mark at 0, and x minus 3, that means there's a 0 at 3, and there's going to be a 0 here at negative 4, and then 1 at 6. All right, the leading coefficient here is a 1, so that means my graph is going to exit the last x-intercept going up. So I'm going to insert some plus symbols here after the last x-intercept. When I get to the 6, which has an exponent of a 1, the sign is going to change because the graph is going to go through the x-axis. When I get to 3, which has an exponent of a 1, the sign is going to change for the same reason. When I get to 0, which I put there because of this x, which comes from a square, the sign repeats because the graph is going to bounce off of the x-axis at that time. And when I get to negative 4, I have a cubic exponent, so the graph is going to cube curve through the graph, so the sign changes. So I'll go mark 6, my zeros, if you will, the x-intercepts. I'll put those on the graph, and negative 4, and I will draw something that is above the x-axis here and go straight through it because of that 1. When I get to this 3, I'm going to go straight through it. When I get to the x squared, I'm going to bounce off of it because of the x squared. And when I get to this last one, I'm going to try to draw a cubic curve as best I can. Close enough. All right. B needs to be factored first. So I see I can take an x squared out of both of those terms, which would leave behind a 16 minus x squared. And the 16 minus x squared factors again to a 4 minus x and a 4 plus x. So on my number line here, I'm going to go mark 0 again, and 4 from that binomial, and negative 4 from the other one. And now the part that's a little bit tricky. The leading coefficient obviously is the coefficient in front of our dominant term here, and that's the 4, and it's a negative right there. That negative tells me that this graph exits heading downward, or minus signs. And if you need to rearrange that equation to see that, the term that has the largest exponent traditionally should be written first. And if we wrote it first, you would see that guy is with a negative that determines those minus signs. All right, I put this 4 there because of this binomial. That has a 1, so the signs are going to change. We put 0 there because of this guy. It's an x squared, so the signs repeat. And negative 4 we put because of this guy. The exponent is a 1, so the signs change. All right, negative 4 and 0 and 4 go on my number line. This graph is headed downward, so I'm going to run straight through that 0, that x-intercept. I'm going to bounce off this x-intercept, and then I'm going to head straight through this one. A 1 and a 1 and a 2, 1 and a 1 and a 2. We're there. Okay. B on problem 31 just says, find the equation of this polynomial graph. So I'm going to write the letter A. We're going to find that later. We're going to use that coordinate point to help us figure that out. Let's insert all the binomials that would get us the correct zeros here. So that's negative 5, and it bounces off of it. So x plus 5 must be squared. This is negative 1 that it's running through, and it's cubing through it. So x plus 1 cubed. And that's bouncing off of positive 4. So we're going to have x minus 4 with a bounce off squared. Now I take my coordinate point, insert the y value for y, and the 2 goes in for all the x's. Now 2 plus 5 is 7, and 7 squared is 49. 2 plus 1 is 3, 3 cubed is 27, and 2 minus 4 is negative 2, and negative 2 squared is 4. So that ginormous number right there is 49 times 27 times 4. So that's what all of that equals, which I would then need to divide by. So this side over here, negative 144 divided by 5292. If we wanted to simplify that, I could punch that on my calculator, get some weird decimal, and then if I hit math, enter, it'll convert it to a fraction. That's the reduced fraction, which it didn't say you had to have. It was negative, which I left off when I typed it. So the reduced fraction would give us this. Okay. And let's go ahead and slide down here to 32, the first part of 32, so I think it's continued on the next page. For each equation, find the degree and the types of roots that it has. All right, so our degree, let's just abbreviate that with a D. Here's 3, 4, 5, 6, 7, 8. We have a degree of 8. So our roots, which are zeros, are going to add to 8. I have one triple root here, so in no particular order, let's do one triple. Here's a double, so I have two doubles. Here's my single, one single, or should I put that one single? And one triple counts for 3 of the degree we need to add to. Two doubles count for another 4, so 3 plus 4 is 7, a single is 8. So we are accounted for, and we don't need any complex roots. B requires you to factor first. So I'm going to pull an x to the third out of all of this madness. And then I'm going to factor that remaining polynomial into binomials. And we got it to factor, which is great. Let's see, there's our degree right there, right? It's the largest exponent if everything is multiplied together. So since everything's all multiplied together, there we have a degree of 5. We have one triple root and two singles. And that takes care of all 5. And C. All right, let's head to the degree. Here's an x squared, so there's 2. Here's an x squared, so that makes 4. Here's an x squared, so we have 6. Degree of 6. Here's a double root, and then we got to watch out. Okay, so if I were to set this guy equal to 0 all by himself, and I'll give you a visual. If you were to set it equal to 0, because that's what you would do to find the x-intercept, you would notice that you would get x squared equals -3, and x squared can't equal -3. So that guy doesn't actually produce any x-intercepts. There's nothing you can put in there except an imaginary number, which is a complex number, which we're trying to find anyways. So that guy doesn't provide any real answers. This guy here, if it doesn't factor, which it doesn't, you would use the quadratic formula to see if it equaled 0. And when you head to the quadratic formula, negative b plus or minus b squared minus 4 times 1 times 9 is 36. And I can stop right there. As soon as you see that you're going to get the square root of a negative number, it doesn't have any real roots either. So no real roots from these two guys. They both got imaginary numbers. So my root here, I have one double, and the other 4 are all complex. And there's our 6th degree that we needed. All right, over here at D, looks like we are going to take out a 2x to start this factoring. That's going to leave behind an x squared minus 2x plus 4. This doesn't factor any farther. So let's see if it has two answers that could be cruddy decimals. You know, you could use a quadratic formula and get cruddy decimals, and that's totally fine. Those are technically real roots. But if I head to the quadratic formula here, negative b plus or minus b squared minus 4 times a times c all over 2a. Right there's the negative 12. So this guy doesn't have real. It has complex. So we have a degree, let's put it here, of 3. This guy here is a single, one single root. And these two didn't have any more, so those would be complex. And that adds to 3. All right, I think I'll stop the video there. We'll go to the next page on the next video. See you in a little bit.